Hi again, Pre-Calc students. Time to start Chapter 3, this first lesson on symmetry and coordinate graphs. A lot of this Chapter 3 has some good calculus applications, especially when we get to the end of this chapter, so I think you'll enjoy it. Now, symmetry is something you guys are all pretty familiar with, I think. You have the feel that symmetry means that some kind of image or shape is the same on one side or the other. So as you can see, some symmetry with these particular letters. The line that's drawn here shows that particular line of symmetry. Butterfly is a good example here, where if you fold it over the right wing, it should fold onto the left wing like that. You'll even have a chance to do some projects later on with your name that you can use the letters of your name to illustrate some particular types of symmetry. Here's a key one that we'll talk about, symmetry with respect to the origin. So if you have a particular point on the original graph, in this case we call it AB, then this point is also on the graph, negative A, negative B. So if you think about that, for instance, on this would be like a y equals x to the third graph here. If we have a particular point like 2, 8, which will be on the graph, that will be up here someplace. What the official definition says that also the point negative 2, negative 8 will be on the graph. And we can tell that here by looking at the graph, of course, as well. Now, the visual test, though, is to rotate the image 180 degrees. I won't be able to do that on your viewing screen. But the idea is, if you did that, the graph, of course, would look the same. So we'll actually use a visual test for a lot of these symmetry tests. There is an algebraic way, which we'll talk about here next slide, but for the most part, we'll use more of a visual test. You'll have to graph these functions and then explain from the graph the types of symmetry that it exhibits. Alright, here's a nice chart that you should copy down in your notes. This tells the types of symmetry, the algebraic definition, and then we'll try to write down a little example of what that might look like. So first of all, I'm just going to change my pen thickness here a little bit. Actually, like that. There we go. Okay. So symmetry with the x-axis, algebraic definition, you can see it's not the x values that change, it's actually the y values that change. Here would be a good example of something that's symmetric over the x-axis. So if I had a point here like 2, 3, so then also the point 2, negative 3 would be on the axis like this. Now the only trouble with this, I think you can see, is that the example I drew here is not a function. So we won't see too many symmetries of the x-axis with functions anyway. Now looking at the next one, the y-axis, this is a little bit more familiar one. There's the algebraic definition. Here would be maybe a good example of that, any kind of parabola that has its center on that y-axis. You can fold it over the y-axis, and of course it would fold onto itself. So that's an easier one to recognize. The line y equals x, which you probably know is the line that oops, gotta get back to my pen here. The line that sneaks through the origin like that at a 45-degree angle. We could draw some kind of graphs that have that kind of symmetry. You can see what the algebraic definition is, just reversing the x and y essentially to be symmetric with that. That's a little bit trickier maybe to show an example of, but let's just see what we can do on this. If I just drew some sort of a straight line in there like that, maybe even a straight line like this might exhibit some symmetry with that line y equals x. That's a pretty good example too. And of course the line y equals negative x, that is similar to y equals x, except it just comes in at a different angle, still crosses the origin like that. And we could come up with some examples of that, which would be symmetric. Again, it has to be able to fold over this particular line in order for it to be symmetric. But as we'll see, we won't use these definitions a great deal. We'll rely more on the visual ones in order to demonstrate what kind of symmetry a particular function has. So here's a first good example. Most of the time we'll actually give you a function like this and you'll have to determine the symmetry. So this is the opposite of the absolute value of x plus 3. So you can see here's what the graph looks like. And we would say the symmetry for this one would be certainly the y-axis. Oops. Keep getting confused here with my pen. The y-axis, because if we fold this over the y-axis, you can see that the graph would fold onto itself. Are there any other ones here? Well, again, the x-axis won't work because this would have to be a non-function. This is clearly a function. The other two lines we talked about also would not work either in this case. So this one, the only symmetry it has is of the y-axis. Now, here's a trickier one. Determine the symmetries of this. This one has some squaring in it. Now, you might be tempted in trying to graph this anyway, that maybe you take the square root of each side. So the square root of y squared, of course, is y. And then you might think that, well, if I took the square root of 4x squared minus 16, that I could just take the square root of each particular piece here and get 2x minus 4. However, this would not be correct, mainly because of that minus sign in there. And so I would guard against doing that. We'd have to say that this is not equal to that. So how do we actually go about figuring out the symmetries here? Well, we can still use this part. In fact, we can enter this in our calculator, that y equals the square root of 4x squared minus 16. My next slide will be a little bit of what that looks like. So that's our first entry there, the square root of 4x squared minus 16, which should give you the right-hand picture here that we have. But because we're taking a square root, we also need the opposite of that, the negative square root of 4x squared minus 16, which will actually give you this portion of the graph. So whenever you have a squared, an x squared or a y squared, and especially if you have to solve this for y, watch out for this to include both parts of that. Now, what kind of symmetry would you say this has? Well, certainly it looks like it's symmetric with the y-axis. You could fold it over the y-axis. And I think you could also say in this case it's going to be symmetric with the x-axis as well. So those would be the two types of symmetry in this particular case. One thing that we're going to have you do, possible project, is see if you could write your name with some sort of symmetry. You'll see that option on the assignment card to talk more about that, but that's kind of a fun little thing to do to help you get a better feel for symmetry. Alright, well, thanks for watching, gang, and we'll see you guys in class.